Hi everyone. In this chapter we will be studying linear functions. In this lesson we will be looking at the slope y-intercept form of the equation of a line.
Alright, in this particular lesson we are looking really specifically at the slope-intercept form of a line. This is something that you're already sort of familiar with because in a previous chapter here we'd already started to build this equation because it's a very natural way to look at a scenario and model it. So for example, in the relations and functions chapter we looked at car rental costs. So let's say you're going to rent a car. Well, you'll notice that in this particular case here what we're seeing is the initial cost of the vehicle is 60 bucks, okay? And we knew even in that context to relate initial costs to the y-intercept, okay? So that right there represented the initial cost, and it was, in fact, it was the same thing as the y-intercept. And then we knew that when we were getting charged 20 cents per kilometer here, okay, that was a rate of change. And then so that what we did is to build the equation, we multiplied that rate of change by the value of the independent variable, and then added that extra value there that was given to us initially, that initial charge, if you will. Even if you didn't drive it, the fact that they let you have the car, that's going to cost you 60 bucks. So that built this equation right here. Notice that the rate of change is always the coefficient of the independent variable. Now, and in this new context, that's the slope, and that's the y-intercept. Now, this gives us this form right here. Now, I've already been using m to represent slope. If you haven't already noticed that, it's just a go-to. I don't even notice oftentimes that I'm doing it. But yeah, there's our rate of change. It's the coefficient of the independent variable, and then we've got the y-intercept that sits at the back of that equation there. This is the equation of a line, or the first equation of a line that we're going to spend some time looking at. And it is the most natural one, like I said up here. It's just if I was to ask you to create an equation based on this information, almost all of you would jump to this one right here, okay, as a way of modeling what's going on here. Now, I want you to recognize that that's the slope, that the coefficient right there is the slope, this is the y-intercept, so that you can make the jump directly to the graph here. So for example, this line right here, notice it's got a y-intercept of 1. And then the slope, well, I can count out the slope. I know that it goes from here. I'm going, what is it? I'm going up 2 over 1 to find another point here. That's a slope of 2 over 1, so my slope is 2. That means the equation of this line must be y equals 2x plus 1. Slope times the independent variable plus the y-intercept. Okay, and now, well, we're going to do some examples with this. I want you to know that, and well, another thing that I should actually encourage you to focus on right here is that notice that the equation of the line is in this form when the y is isolated and the other side is simplified. Okay, this form occurs automatically when y is isolated. Now at this point you might not exactly know where I'm going with that. Like, why would I bring that up? Why would I bother saying that? But you'll see why I say that in a bit here, because in other forms of the equation that we're going to look at, y isn't going to be isolated. And so oftentimes the slope and the y-intercept won't be so clear. This is the form of the line that it's the clearest in. And in order to get it in that form, you need to make it y equals. Now, we'll see some examples of that a little bit later on here. For right now, let's just make sure that we understand how to pull the information out of that equation. Okay, so for these questions right here, we're just going to pull the slope and the y-intercept out of each of the following. So to start off with, I've got y is equal to x plus 2. So what's the slope? Okay, well, the slope is the coefficient of the independent variable. The independent variable is x. If you don't see a number there, what number is there? Well, 1. So the slope is 1. Now notice it's not 1x, or the slope isn't just x. X is not the slope, x is the independent variable. The slope is the coefficient, the number in front. Now, some of you are really going to have to focus on what I just said there and think about that, okay? Because I see it so often where people try to pull the x in there, but no, that's not what slope is. Now, the y-intercept is the number that's being added or subtracted at the end, the next term here. And in this case, that's just going to be 2. Here, if you understood this here, this is probably a little easier. The number in front here is going to be 3/2. The coefficient of the independent variable here is 3/2. And then the y-intercept here is -1. Now, be aware that this could have been written 3x over 2 minus 1. Okay, maybe we'll zoom in on that a little bit. This could have been written as 3x over 2, in which case the coefficient of x is still 3/2. Don't get locked into this idea of thinking, no, the coefficient's just 3, and then I divide it by 2, because then I'll have to turn around to you and say, no. Remember, this can be rewritten as 3 over 2 times x. These are exactly the same. Okay? So whether the coefficient, whether there's part of it in the numerator or part of it in the denominator, okay, that part there, whatever is being multiplied or divided with the x there, that's all part of that. Okay, let's zoom out again here. Take a look here. What's the coefficient of the x in this case, or the independent variable? Well, it's -1. What number am I adding or subtracting at the end? Well, there isn't anything there. It's just -x. Well, let's think about that. If there's no number there being added or subtracted, what number is it? And the answer is 0. This last one has a similar sort of feel to it. Y equals 3. Now, remember what I've been saying all the way through this, because there's going to be a few of you that'll say, oh, the slope is 3. No, the slope is always the coefficient of the independent variable, the x. Where's x? Well, it's not showing up there. There is no, well, why? Why isn't the x showing up there? Because the coefficient of the x is 0. That's what got rid of it. 0x. Slope is 0. Now, the y-intercept is the number that's being added after that, or that number that sits by itself here, and that's going to be just 3. And so another way of writing this could have been 0x plus 3. And again, but you don't have to write the 0x there. I mean, you can if you need to, but you could have just written this as y equals 3. Okay, slope, and that actually makes sense because we've done this before. We've already looked at equations like this, and if you got y equals a number like that, remember that's just a horizontal line, the slope is 0. All right, so now we're going to go backwards here. I'm going to write the equation of the line in the form y equals mx plus b, slope-intercept form. Slope is 4, y-intercept is 8. So that's easy, automatic, 4 in front of the x, and then we add the y-intercept down on at the back here. Here, slope is 3/2, and the y-intercept is -4. So 3/2 is the coefficient of the x, and then we subtract the 4. Or y equals 3x over 2 minus 4. I'm going to keep pushing this because I need you to see that those are identical. Order does not matter too much if you're talking about multiplication and division. And the reason for that is dividing by 2 is really the same as multiplying by 1/2. And so just by kind of rethinking the way the question is being worded there, I can get around the order issue. Okay, I hope that makes sense. All right, now here's another important skill. I need you to be able to go back and forth from the graph to the equation here. So take a look at this guy right here. Y equals... And notice that every time I write the equation, there's always a y and an x in there. Now to start off with, I need the slope. I'm going to use these 2 points right here. So to go from there to there, I'm going to drop 1, 2, 3, 4, 5, 6. Makes sense because the y-intercept was 6. The run is 1, 2, 3, 4, 5, 6, 7, 8, 9. So this was -6 over 9 times x. And then my y-intercept, I read that right off, is just where I cross the y-axis, is going to be +6. Now, that's correct, but not simplified. I want to simplify this -6/9. Okay, there's a common factor of 3 to both of those, so this is going to be -2 over 3x plus 6. That's the equation that we want to use. Over here, same thing, y equals, okay, what's the slope? Well, let's take a quick look here. These 2 points are quite clear on the graph here. And the slope from between those two, is, I counted out here, is going to be 1, 2 over 1. So this is going to be just 2x. And the y-intercept here is negative 2. Now over here, okay, the slope is, because it's a horizontal line, the slope is 0. So I might write this as 0x, and then the y-intercept is negative 4. But that seems kind of odd to write it like that. So I'm just going to, 0 times x is just 0, minus 4 is negative 4. That's a, sorry, a better way of writing that line. Now over here, we need to talk about this one. The slope of this line is undefined. Well, okay, don't be the one who does this. Ah, that's undefined times x, and then the y-intercept is, well, I don't know. Okay, that's not an equation you can use. That doesn't make any sense. The problem here is that all these other ones here are functions. This one isn't. Y equals mx plus b is the equation of a linear function. And now we're going to use that word, and it's going to mean something. Here, this is just a linear relation. And we've talked about this before. The only way that you can really identify that is to identify what stays constant. And in this case, what is constant is that the x value is always 5. Okay, cannot be put into slope-intercept form. That's the exception to the rule. And again, it's because it's not a function. Right, now we get to go the other direction here. Here's the equation. Now we're going to come up with the line here. So, take a look at this. Slope-intercept form. Slope is the coefficient of the independent variable, and the y-intercept is the value, the constant that we add at the end. That's 3, so that means on the y-axis I go to 3. And what does this mean as a slope? Negative 2. Slope is equal to negative 2. I'll write that over 1. So down 2 over 1. And just as I've done previously, I'm going to pull out a ruler here, just so that it looks better here, but this is not absolutely necessary, as long as I can see that you've got a slope where you're going down 2 over 1. And there we go. All right? Over here. What have we got here? Well, look at the y-intercept first. We want to look at the y-intercept first because that is going to give us an anchor point on this graph, somewhere where we can build out from. So I know that this graph goes through the point 0, negative 4. So it's going to go right there. The slope is 1 over 2, meaning a rise of 1 for a run of 2. So there's the next point on there. And now I'm going to just connect those dots. Now I know that, okay, that I should be going 1 up 2 over for all of these. So I just want to make sure that I'm hitting all those points there. Okay. That wasn't great. It should have been down just a very, very little bit, but you get the idea. Okay, going through negative 4 with a slope of 1/2. Over here, and I knew this one was coming here, something like this. The y-intercept of this is 2. Where I suspect people are going to look at this and have problems is figuring out what the slope is. What's the coefficient of the independent variable? What's the coefficient of x? Don't say it's 1. It's not 1. Dividing by 3 is the same as multiplying by 1/3. You need to be flexible enough in your thinking to see that. The slope here is 1/3, so meaning I've got a rise of 1 and a run of 3. So 1, 2, 3. Okay. And then there we go. And so there's our line. Goes through positive 2, rise of 1, run of 3. Now in this particular question, we're going back to what we did in a previous lesson. We're going to determine whether lines are parallel or perpendicular or neither. Okay. Now to do that though, remember we need to compare slopes. Parallel means same slope. Perpendicular means negative reciprocal slope. Well, now you should be much more comfortable. You know where you're looking for the slope. So for this first one, the slope is negative 1/3. For the second one, the slope is 3. These are the coefficients of the independent variable. Notice this is negative, this one's positive. This is 1/3, this is 3 over 1. That's exactly what I need for these to be perpendicular. Negative reciprocals. Here, again, coefficient of the independent variable, 4/3. Coefficient of the independent variable, 4/3. They are exactly the same, and we know that that means that those two lines are parallel. Here, the slope is 1/2. Here, the slope is 2. Now, notice 1/2 and 2 are reciprocals of each other, but because they're both positive, that's not enough to satisfy the conditions for perpendicular. So the best we can say is that these are neither parallel nor perpendicular. They're just kind of, they're at an angle to each other. Okay? There you go. Okay, so for this next series of questions here, we're going to treat these all as if they're really just one question, because they really are asking the same thing over and over again, but with slight variations here and there. We're going to come up with the equation in slope-intercept form. So look at the information that we're given here. So maybe we'll zoom in a little bit here. So first of all, we're going to grab a line that has a slope of 3 that passes through the point -1, 2. Now that's not the y-intercept. And this is one point. I've seen people make the mistake here of thinking this is two separate points here, like x is 1, y is 2, and then like that's the x-intercept, this is the y-intercept. That's not true. This is the point -1, 2. So this is the form of the equation that I'm looking for. I've given you that the slope is 3, so that's y is equal to 3x plus b. Now, this is going to let me know right away how comfortable you are with what a point is. Bear in mind that the point is x comma y. That x, that y. When I plug this point in for x and y in the equation, it should make the left side and the right side equal. So by plugging -1 in for x, this becomes 3 times -1 plus b, and y becomes 2. That point should make this equation true. Now, once I've plugged that in, the only unknown I have is b. I'll simplify the right-hand side. This is going to be 3 times -1 is -3. And then I will add 3 to both sides to get that b is equal to 5. The y-intercept is 5. Now that I know the y-intercept, I can write that the equation is 3x plus 5. Bearing in mind that an equation needs to have an independent and dependent variable in it. So the y and the x have to be there, and then I just need to figure out what the slope and the y-intercept are. Let's look at the next question. Very, very similar sort of question, just this time we've got a fraction for the slope here. So y equals mx plus b is my starting point. I know that my slope is 1/3. The point that it's going through is the point -8, -3. Now bear in mind that's the value for x, this is the value for y. So I plug that in. -3 is equal to 1/3 times -8 plus b. So now I've got an equation where the only unknown is the b, the y-intercept. Now let's simplify that. So -3 is going to equal -8/3 plus b. That's -8 times 1/3. Now remember, you don't distribute the -8 to the numerator and denominator. This is like -8 over 1. And so you multiply numerators, multiply denominators. Now, to isolate the b, I'm going to add 8/3 to both sides. So -3 plus 8/3 is equal to b. Well, -3 over 1 plus 8/3. This is like -9/3 plus 8/3. So it'll be -1/3 is equal to b. And then putting that all together, I get y is equal to 1/3 x minus 1/3. That's the equation that we're looking for. Now here, I'm giving you the exact same information that I've given you the previous questions here. It's just that in this case, I'm not telling you the point overtly. You've got to know that if it's the x-intercept is is 7, that is the point 7, 0. You've got to know that. So again, we start with y equals mx plus b. We know that the slope is -2/5 x plus b. And so now I'm going to plug in the point 7, 0. Okay, 0 in for y, 7 in for x. And I'll simplify that first. So -2/5 of 7 is going to be -14/5. And then to isolate the b, to get that by itself, I will bring the 14/5 over, just add it to both sides. Now in this case, as soon as I do that, I know what b is. And so now I can write the equation. Y is equal to negative 2/5 x plus 14/5. Whoops, plus 14/5. That's the equation I'm looking for. Now, obviously we're going to have some cases here where things are a little bit different. You're always going to get stuff like this. What if the slope is 0? Okay, and the passes through the point 4, 1 here. Well, if the slope is 0, that's 0x plus b. Well, now I can plug that in. Y is equal to b. Now, plug in the point 4, 1. Well, you might say, well, there is no x. Yeah, you're right. Okay, horizontal line, x could be everything. The issue is what y is. And so if you plug that in, I get that 1 is equal to b. And so therefore I can rewrite this as y is equal to 1. All the points on that line, that horizontal line, all of them have the same y coordinate, 1. So just by identifying one point, I can identify the y coordinate for all of them. And that's the way we do that. All right. Here's another way of giving you the information. Now, notice what we're doing here. I've given you 2 points. What you don't have is the slope. But that's okay, because all I need are 2 points to come up with the slope. So I'll make this my second point. So 0 minus negative 3 over 4 minus 0. Well, 0 minus negative 3, this double negative there, so that's going to be positive 3 over 4. Well, there you go. My slope is going to be 3/4. But now don't lose sight of what I've given you here. There's my y-intercept. Remember, the x-coordinate is 0, immediately makes this a y-intercept. So I can just plug in those pieces now. 3/4 x minus 3. There's the equation that I'm looking for. Here, very, very similar sort of problem. It's just this time, I'm not giving you the coordinates per se. I'm giving you the description here. Well, x-intercept of 2 means I've got the point 2, 0 there. Y-intercept of negative 5 means the point is 0, negative 5. Again, I need the slope, but that's okay. I've got 2 points, so I'll let the y-intercept be y2. So negative 5 minus 0 over 0 minus 2. Okay, well, negative 5 minus 0 is just negative 5. 0 minus 2 is negative 2. And so my slope is positive 5/2. Now, there's my slope, and at the same time, I know that the y-intercept is negative 5 because they gave it to me. So the equation is 5/2 x minus 5. There's the equation we're looking for. Here, I've got a slope of 5/3 and the same x-intercept as this line right here. Okay, I'm going to come back to that in a second. Same slope. Okay, it's got a slope of 5/3. So y equals mx plus b. I know right now that that's 5/3 x plus b. Now, okay, has the same x-intercept as this. So they're trying to give me a point to plug in, but instead they've given me an equation and just a reference to it. Well, what's special about the x-intercept? Y is 0 at the x-intercept. Now, what y? That y. Because that y represents the y-coordinate of every point on the line. So when that y is 0, that x corresponds to the x-intercept. So that's going to be 3x plus 4 times 0 equals 12. Okay, well, 4 times 0 is just 0. 3x plus 0 is 3x. And when I divide, I'm going to get x is equal to 4. So this gives me the point 4, 0. That's the x-intercept. So now I'm going to plug that in. 0 is equal to 5/3 times 4 plus b. Okay. Well, let's simplify what's on the right-hand side. 5/3 times 4 will be 20/3. Okay, and I can already hear some people saying, "Whoa, where'd that come from?" Remember, it's not 4 times 5, 4 times 3. 4 is 4 over 1 times 5/3. So 4 times 5, 1 times 3. Bring that over to the other side to isolate, and I will get negative 20/3 is equal to b. There's a little bit more work in this question here, but now I've got all the pieces. I know my slope is 5/3 x, and I know that my y-intercept is negative 20/3. And so there's the equation of my line. Okay, just a few more. Okay, we want the equation of a line passing through the point -1, -5, and perpendicular to this line. Okay, well, what have I been telling you here? Okay, what am I giving you? Well, I'm telling you, so, and by the way, when I say it's perpendicular to this line, notice that it's the slope I'm interested in, not the y-intercept. So the slope of this line is -2/5. The perpendicular slope is going to be positive, and the reciprocal, so positive 5/2. So y equals mx plus b. I know now that the slope is 5/2. And now I know that if I plug that point in -1, -5, it should satisfy this equation. So y is -5. And then the x-coordinate is going to be -1. So this is -5 is equal to -5/2 plus b. So to get b by itself, I will add 5/2 to both sides. So -5 plus 5/2 is equal to b. Yeah, it's like -10/2. -10 is going to be -5/2 is equal to b. So my equation will be 5/2 x minus 5/2 when I put all the pieces in. Okay, now passing through the point 3, 6 and parallel to the y-axis. Okay, now I got to think about this. Parallel to the y-axis means it goes up and down. Okay, its slope is undefined. That's not a function. And because it's not a function, I cannot use the equation y equals mx plus b. That doesn't work. I need another way of writing that down, and bear in mind that every line that's a vertical line, what's characteristic of that is all of the x coordinates there share the exact same value. So if I know the x value of one point, I know the x value of all of them. That's the equation that we're looking for. That's not in slope-intercept form, okay? But that's the right at this point in time. That's the only form of the equation that I can write. And now finally here, if 3, -2 is a point on the line y equals mx plus 4, what's the value of m? So this is kind of a nice one to end off with. I know that this point satisfies that equation. So I know, oops, running out of lead, -2 as the y-coordinate will equal m times 3 plus 4. Now, you can't add the 3 and the 4. So I know some people are tempted to do that, but I can't do that because multiplication comes first. So I'd have to multiply 3 by m before I can add the 4. And I don't know what m is. So really what I'm left with is bring the 4 over, subtract 4 from both sides. I'll get -6 is equal to m times 3, or 3m. And then divide by that 3, and I'll get that m is equal to -2. Good. So hopefully that gives you some confidence in being able to manipulate the equation, to realize the tools that you've got. You in the slope-intercept form, you need the slope and the y-intercept, and you've got a formula for the slope, okay? And if you want to figure out the y-intercept, as long as you've got another point, you can plug that in and solve for it. I hope that helps.